Now this is question 10, which is regarding a cylinder, and we're given some information for this question. We're told that r plus h equals 6. Now, similar to a previous problem, we actually have three variables here, and on the right hand side we just want a single variable, so we need to solve for one of these two variables. I'd rather substitute it for h than r squared, so I'm actually going to rearrange this equation for h. So h is 6 minus r, and then I can substitute that into that equation there. Now, the question for this one is to find the maximums and the minimum values, so I'm going to be differentiating this. So first of all, I want to distribute this, and then now I'm going to work out dv by dr. So bring the power to the front and decrease the power by 1, and the same for this one as well. So our maximum and minimums occur when this equals 0, so we're going to set that equal to 0, and then we're going to solve. There's common factors here. I can certainly see pi, I can see 3 pi, and also there's an r here as well. So we can take that out as well. So when do these two things equal 0? Or when r equals 0, or when r equals 4. Second derivative, so if we differentiate this, so this is just a number, 12 pi. So r to the 1, so the differential of a number and a variable is just the number itself. Bring the 2 to the front, we get 6 pi r to the power of 1, or just 6 pi r. Now if we plug 0 into here, this just becomes 0, so we get 12 pi. And as 12 pi is greater than 0, that gives us a minimum. Probably not surprising really, if we have a radius of 0, that's hardly really even classed as a cylinder anyway. And our other option is when r equals 4, and if you plug r equals 4 into this formula, you get 12 pi minus 24 pi, which is negative 12 pi, so you end up with a maximum. Now we should go back and work out what that is. So for the minimum, obviously the volume is going to be 0, as one of the values is 0, anything times 0 is 0. So we had pi r squared h, and we also had h written as 6 minus r. So if we plug that in, the value of 4, then what we find out is that the maximum volume is 32 pi. So you might want to watch that again, perhaps a little bit slower, pausing occasionally to make sure you can follow each of those steps. But that's question 10 from exercise 7c.